The last 3 sections in Chapter 6 are word problems. None of the word problems are supposed to be that hard. And if I don't, kind of get out of control on explaining theory, this shouldn't be that long of a section. So the first 4 problems give me a formula that's called the compound interest formula. And this formula can be used to figure out how much a single dollar amount will grow to over time if it grows at a certain interest rate, for lack of a better word. And in this formula, there's a ton of letters. We need to know what each of the letters mean. So in this formula, we're going to be finding out how much money a single dollar amount grows to in the future. And the A in this formula is going to be exactly that. It's going to be the future value of your starting investment. So this formula can be used if you start with a certain amount of money and you invest it at a certain interest rate for a certain length of time. It can predict how much money you're going to have in the future. And the A in the formula is the future amount of money. The P in this formula is the starting amount of money. So there's only one A and one P. Inside the parentheses there's an R, and the R is named perfectly. It's the interest rate as a decimal. The N is the tricky letter. The N is how often interest is paid each year. We'll say it's the number of times interest is paid each year. When I was a kid, if you had a savings account, it was real common for the N, the number of times interest to be paid each year, to be 4. And this would be called quarterly compounding if you get interest paid 4 times per year. I think just like back in the 70s, computers weren't as sophisticated as they are now. So the less times you had to do that computation, the better. Now, if you have money in a savings account in a bank, your N might be 12, and that's more common than not. You might get monthly interest or monthly compounding. Compounding probably would be a better word than compounded. N can be 1. That means you only get interest 1 time per year, and we would call that annual compounding. I suppose N could be 365. That would be daily compounding. And there's lots of other options for the N, but these are the common ones. So the N is how many times interest is being paid each year. A lot of times in the word problems, the N isn't given as a number. It's given with one of these keywords, and these keywords we have to turn into a number. And then the only other letter I see in the problem that I haven't talked about, there's 2 N's and then there's a T. The T is the number of years that the investment is held for. So this formula, if you give me an amount of money that you invest, if you give me an interest rate and how many times interest is being paid each year, and you give me a number of years, this formula, if you put those numbers into the formula, will kick out how much money you'll have in that many years in the future. The first 4 problems are really pretty straightforward problems. They're just complete applications of this, just getting used to using the formula. So if I look at number 1, because it tells me in this group of problems that I have to use this formula, To solve a problem with the compound interest formula, I need to read through the problem and figure out what each number means, or what each word means if there's a word that triggers a number. And as I read through this problem, number 2, it says an initial deposit of $1,000. That's a dollar amount. And in my formula, there's 2 letters for dollar amounts. A is the future amount of money. P is the starting amount of money. As I read through this, it says how much will, and it says an initial deposit. So that 1,000, I'm assuming, is going to be a P, because initial seems like a starting amount to me. So when I go to solve this problem, I don't really even know what the question is asking yet, but I know in this formula I'm going to plug 1,000 for P. The next number I see is 3% interest, and I know that the interest is the R in the formula, and when I wrote this up, I said it needs to be the interest rate as a decimal. To change 3% into a decimal, it's going to be 0.03. So I'm not even done with the first sentence, and I have 2 values for my equation. As I finish up the first sentence, initial deposit of $1,000 earns 3% interest compounded monthly. Usually the N is given with a word, and it's usually the word that follows compounded. And if I look at my statement here, monthly compounding, or compounded monthly, implies an N equals to 12 because there's 12 months in a year. So that bit that I highlighted right there is actually going to give me a value for N. And N's going to be 12 because there's 12 months in the year. Finally done with the first sentence, I have 3 values. And then the second sentence, or second part of this, has the question that needs to be answered, and it has one more number. How much will be in the account after 10 years? The 10 years is a T because it's a time. And what I'm solving for is how much is going to be in the account after 10 years. I'm solving for the future amount of money. So the A is what I'm solving for. So what I'm going to do is I'm going to put the numbers that I know into the formula and leave the number I don't know as a letter. So into the formula, I'm going to leave the A that I don't know, the amount of money I'm going to have in the future, as an A. And for the P, I'm going to put the number 1,000. I'm going to put the parentheses, then the 1, and then plus, and then a fraction. And for the R, I'm going to put the decimal version of 3%, which is 0.03. And for the N, I'm going to put the 12 times interest is being paid each year. Close out the parentheses, and then the exponent needs to be 12 for N times T, which is 10. When I go to do this problem, it's now just completely a calculator problem. If I don't multiply out the exponent, my calculator needs the exponent to be in a parentheses. So on my calculator, I'm going to get my answer by just entering this junk, and I'm going to go 1,000. I won't need the times sign. I'll go parentheses 1 plus 0.03. I'll hit the divide sign. My calculator will put a slash when I do the divide sign. Divide it by 12. And for the exponent, I hit the up arrow key. If I don't type in 120, which is what 12 times 10 is, I have to put the 12 times 10 in a parentheses. If you don't put the exponent in the parentheses and the exponent has multiplication, it'll think of that 10 as not being part of the exponent. So let me just do this best I can now. So I'm going to go 1,000, parentheses 1 plus 0.03 divided by 12, up arrow, 12 times 10. And because this is money, even though the problem didn't say to round to 2 decimals, I'm going to round to 2 decimals. Let me show you what would happen if I did that 12 times 10 and wrote it as 100. So another way to do this on my calculator would have just have been to type in up arrow 120 right there instead of 12 times 10 in a parentheses. And if I do the multiplication, I don't need the parentheses. So if I did 1,000 times 1 plus 0.03 divided by 12, up arrow 120, and doing that multiplication by myself, I don't need the exponent in the parentheses, so I'll get the exact same number. If I didn't put the 12 times 10 in a parentheses and I did 1,000 times 1 plus 0.03 divided by 12, up arrow, 12 times 10. You'll watch that this number that I've gotten twice, I won't get anymore. You get a completely wrong number. So if you don't do the multiplication of the exponent, it needs to be, that multiplication needs to go in a parentheses. All right, so I'm ready to answer my question. How much will be in the account after 10 years? This $1,349.35 will be in the account in 10 years. I rounded to 2 decimal places because money doesn't make sense to give more than 2 decimal places. And I put a dollar sign next to the number that indicate this is the dollar amount. But I could say $1,349.35 will be in the account in 10 years. If I wanted to do that as an answer. It's absolutely not necessary to write that much. I won't probably, again, write this much as an answer. So how much will be in the account? This would be completely fine for an answer. A dollar sign, maybe a comma. $1,349.35 will be in the account, which means the account got $349.35 worth of interest over those 10 years. So your problem 1 should be more or less the same. As I go through your problem, the first number you're going to get is a P that's going to be 1,000. You're going to get an R, but you need to change that into a decimal of 0.04. And then right where I got my 12 for my N, you're going to get a 2 for your N. It says compounded twice per year. That means the N is going to be 2. In the last sentence, how much will be in the account after 5 years? The T is going to be 5. You'll put those 4 values into the right side of this formula, and it will enter it on your calculator, and you'll get how much will be in the account after 5 years. All right. 3 and 4 are essentially the same problem with different numbers. I do that a lot with word problems. So as I read through the problem, an initial deposit of $12,000. So that $12,000, because it's a starting amount of money, and because P is a starting amount of money, I'm going to put into my formula 12,000 for P. The next thing I see is earns 1% interest. That's unfortunately the kind of interest you can get now, which makes your money not really grow at all. And that 1% interest is my R. I need to do the decimal form of that. The decimal form of 1% is 0.01. Into my formula, I'm going to plug in 0.01 for R. As I finish out the first sentence, I see words that imply what the N is. The compounded quarterly tells me how many times each year the interest is going to be paid. And quarterly compounding means N is equal to 4. How much will be in the account after 10 years? The last number I see stands for the number of years. A T stands for the number of years, so I'm going to plug in T equal to 10. So I'm going to take those 4 numbers and plug them into the formula. I'll get A equals to 12,000 times 1 plus 0.01 over 4 to the 4 times 10 power. And I'll enter that on my calculator. So on my calculator, I'm going to enter 12,000 parentheses 1 plus 0.01. I'll type the divide key. It'll show a slash. Divide it by 4. Up arrow. It's probably easier to do up arrow 40. But if you want to do 4 times 10, you have to put it in a parentheses. If you don't put the 10 in a parentheses with the 4, you'll get the wrong answer. If you just make a 40 there, you'll still get the right answer. So now it's just calculator time. So 12,000 times parentheses 1 plus 0.01 divided by 4. Up arrow 4 times 10, or I could have did up arrow 40. And I'm going to round that to 2 decimal places. Then unfortunately, this is a hard rounding, so let me explain it a little bit just in case it's not obvious to you. So to round to 2 decimal places, the number in the second decimal place is a 9. It's either going to stay a 9 or round up to a 10. Because the number after the 9 is a 6, that 9 rounds up to a 10. And I need to carry the 1 over that I bumped up and round the 3 up to a 4. So my answer for problem 4 is the amount of money I'm going to have in 10 years is $13,360.41, and that feels like a lot. It's surprising to me they get that much money, but I guess it's correct. With math error somewhere, and I'm not sure. I just did this problem again off screen, and no, I didn't. Yeah, I guess that's right. I just did it off screen, and it worked. All right, so the first 4 problems use the compound interest formula. The second group of problems use a different formula, and it's called the continuous interest formula. So in problems 5 through 8, there's a new formula presented, and I call this the continuous interest formula, or continuous compound interest formula. So this formula for 5 through 8, A equals PE to the RT, we call this the continuous compound interest formula. And if you compare the two formulas, they don't have exactly the same letters, but they have mostly the same letters. They have the letter A, they have the letter P in common, they have the letter R in common, they have the letter T in common, but the compound interest formula that we worked for problems 1 through 4 has an N. This one doesn't have an N. For this group of problems, interest is being paid more than every second of every day. In this particular group of problems, interest is being paid every instant of every day, and the N is equal to infinity. And unfortunately, there's no way to do an infinity on my calculator. So this formula is what happens essentially when you plug infinity in for N, because E is equal to 1 plus 1 over infinity to the infinity power. And if you plug infinities in for the N's in this compound interest formula, you get 1 plus R over infinity to the infinity times T power. And that's approximately, that's how the E comes up, because you get kind of the shell of an E in here. So this formula is used when interest is being paid more than quarterly, more than 4 times per year, more than monthly, more than 12 times per year, more than daily, more than 365 times per year. This is the continuous interest formula. It's paid when it is used when interest is being paid continuously, which means more than every second of every year. It'll be real easy to tell when you need to use this formula. First of all, it's going to be given to you, and then second of all, somewhere in the problem it's going to say the interest is being paid continuously, which implies the N is infinity, which means I can't use this formula because I don't have an infinity button on my calculator. So in this formula, the A equals PE to the RT formula, the A is still the future amount of money. The P is still the starting amount of money. The E looks like it's an unknown. It's not an unknown. E is 2.718 and it's a decimal, it's a number, so it's not an unknown. We'll never plug something in for e. In fact, if I do second and divide on my calculator will give me that many decimals for e. E has way more decimals than that, and there's no pattern to e. It looks like there's a pattern here, but there isn't a pattern to e in general if you give it more decimals. So e is not going to be an unknown. I'm not going to ever put anything in for e. The r is still the interest rate as a decimal. And the t is still the number of years. So for the next 4 problems, 5, 6, 7, and 8, I'm going to use this formula specifically because I'm going to work with money growing at a continuous compounding, which means the n is infinity, which means that formula is impractical to use on my calculator. So let me see if I can use this formula. An initial investment of $10,000, boom, initial investment, that means the P is equal to 10,000. Earns 5.25%, that means the R, make that a decimal, by doing that you move the decimal to the left and you get 0.0525 is R. So an initial investment of $10,000 earns 5.25% compounded continuously. Compounded continuously means the n is infinity, so I can't use the other formula. I need to use a formula with the e. The compounded continuously kind of generates the e in the formula. And then what will the investment be worth in 8 years? As I finish up this, what will the investment be worth in 8 years? 8 is a t because it stands for the number of years. So now I'm going to use the formula A equals P e to the RT to answer my question. I'm trying to find out what A is equal to because I'm trying to find out how much money the account's going to have in 8 years. So I'm going to solve for A. I'm going to plug these 3 numbers into the formula. I'm going to use my calculator. So I'm going to get A equals to 10,000 times e to the 0.0525 times 8. And on my calculator, it's a little bit trickier. On my calculator, to get my answer that I'm going to round to 2 decimals, I'm going to type 10,000, and then I'm going to hit the second and the ln key. My calculator, when I do that, will come back with an e, with an exponent, and it'll give a parentheses. And inside that parentheses, I'm going to plug it 0.0525 times 8, and I'm going to close out the parentheses. And that should give me the answer that I need. So let me do this. 10,000, and then second in ln, and then 0.0525 times 8. Close out the parentheses. I'm going to round this to 2 decimals. The number in the second decimal is a 1. After it is a 5, I'm going to round that 1 up to a 2. And for my answer, in 8 years, this account's going to have $15,219.62. I could write a sentence saying the count in 8 years, the account will have that amount, but I don't have to. So for these problems in this section, my answer is just, if I'm trying to find a dollar amount, I'm just going to write that dollar amount in a box with a dollar sign. So your problem 5 should work real similarly. As we read through problem 5, the first number I see is the initial investment. It's the starting amount of money, so it's the P. The second number I see earns 6% interest rate. It's the R, but the R has to be made into a decimal, so we'll make that into 0.06. It earns interest compounded continuously, so the n is infinity, so I can't use the compound interest formula that I use for problems 1 through 4. I have to use this formula. That just tells me, the continuously tells me I need to use that formula. What will the investment be worth in 5 years? The t is going to be equal to 5, and you're going to solve for A just like I did. Alright, so 7 and 8 are essentially the same problems. So let's see what we can do with those. As I read through this problem, it gives me the formula, so I know which formula I'm using. An initial investment of $120,000, that's going to be my P. Earns 2.25%. I'm going to drag the decimal over 2 and make my R equal to 0.0225. So the initial investment P of $120,000 earns 2.25% interest compounded continuously. That's the R. The continuously tells me I need the formula with the E. What will the investment be worth in 22 years? The T is going to be 22, and the A is what I'm solving for. I want to find out how much the investment's going to be worth in 22 years. So I'm going to solve for A. I'm going to plug the numbers into the formula, so I'm going to use the formula A equals PE to the RT. I'm going to leave A unknown. In for P, I'm going to plug 120,000. I'm going to leave the E, and then I'm going to plug in 0.0225 for the R and 22 for the T. And on my calculator, I'm going to type 120,000. Then I'm going to hit the second key and the ln key, and my calculator will come back with an E, a parentheses, and an exponent, and I'm going to type 0.0225 times 22, and whatever I get, I'm going to round to 2 decimals and just write that as my answer. So I'm going to go 120,000, make sure I get all the zeros, and then second and ln for the E, 0.0225 times 22, and the number in the second decimal place is an 8. I'm either going to leave an 8 or round it up to a 9, because the number after it's big enough, I'm going to round that up to 79 cents. So for my answer, I'm going to write in a box maybe with a dollar sign. The how much is going to be $196,859, and then I'm going to round that to 79 cents. So your problem 7 should work essentially identically, so pause the video and give that a go. And then we'll get to some word problems that are a little bit harder. Problems 9, 10, 11, and 12 are quite a bit harder in terms of they're going to ask us to solve for T, which means the algebra is going to be a little bit nastier. So, could do something to make your life easy, or we could just do the algebra. Oh, I'm debating. If I did something to make your life easy, it'd be kind of confusing to follow. So I'm just going to do the algebra. So if I read through number 10, the first 2 words I see is how long. I didn't see how much. How long means I'm going to solve. The how tells me that's the question. In the last few problems, oh, it doesn't say even how. I say what will be the investment. Well, where the question is tells you what we're solving for. And in this case, how long means I'm going to solve for T, because T is the length of time. So how long, solve for T, will it take an initial investment of $1,000? So that right there, that $1,000, the first number I see is the starting amount of money. It's a P. Right after the words, how long will it take an initial investment of $1,000, I see the words to double. This is sneaky. This tells me the A, the future amount of money, without giving it as a dollar amount. If I want to double $1,000, I'm going to multiply $1,000 by 2 and get the future amount $2,000. Essentially, this is saying how long will it take an initial investment of $1,000 to grow to a future investment of $2,000. So these 2 words right here physically give me the P, the starting investment of $1,000, and implies the A, the future amount of $2,000. If I continue reading, if it is expected to earn 6%, that 6% is going to be my R, and I'm going to make it 0.06. So if it's expected to earn 6% compounded continuously. Notice I have 4 letters, A, P, R, and T in this problem, and I have values for 3 of them. The fourth letter, the T, is what I need to solve for. So even if I didn't know from the words how long that means solve for T, if I correctly pull the numbers out of the problem that are either given or implied, it'll leave the T as the unknown. So I'm going to use that formula, and now a little bit of algebra. So I'm going to use the formula A equals P e to the RT. I'm going to plug in 2,000 for A. I'm going to plug in 1,000 for P. I'm going to leave the EE. I'm going to put 0.06 in for R, and I'm going to leave the T unknown. A little bit more work to solve this than any of the other problems because the letter that I'm solving for is in an exponent. Because the letter I'm solving for is in an exponent, I'm going to need to use logarithms to solve. So the algebraic way to get this T solved for is to first get the coefficient of 1,000 away from the E by dividing both sides by 1,000. On the left-hand side, if you do this division, you'll just get 2. Now I have an exponential equation, and to solve exponential equations, we'll take the logarithm of both sides. In this case, I'm going to take the natural log of both sides. So step 1, after I create the formula, divide by the number in front of the E. Step 2, take the natural log of both sides. Step 3, make the exponent into a coefficient. Step 4, replace the natural log of E of 1 because the natural log of E is equal to 1. So on the right-hand side, this is really 0.06t times 1, which is 0.06t. So now I have the natural log of 2 equals 0.06t. I'm going to divide both sides by 0.06. I'm trying to solve for t, and I've successfully solved for t, except I don't have a good value for that. Right now I have t equals to the natural log of 2 divided by 0.06. That's technically an answer. That's what t equals to, but that definitely isn't a great answer. The instructions say round to 1 decimal place, so I'm going to pull out my calculator. And on my calculator, I'm going to enter ln. My calculator is going to force that 2 to be in a parentheses. Then I'm going to hit the divide key and type 0.06. And I'm going to get an answer that stands for t, the number of years, and I'm going to round to just 1 decimal. So I'm going to do ln of 2 divided by 0.06. And you get 11 it says round to 1 decimal place. The number in the first decimal place is a 5. It's either going to stay a 5 or round up to a 6. Because the number after it is bigger than 5 or bigger, I'm going to round it to 11.6 years. My answer is not going to be money because I'm solving for the number of years. So my answer for problem 10 is going to be t equals 11.6. And then I'm going to put a word after it. I couldn't put a dollar amount because time isn't dollars, or it kind of is, but time is years in this case. So your problem 9 should work real similar. As you read through it, your problem 9 and my problem 10 are worded real similarly. The first 2 words are how long in problem 9, which means I need to solve for t. Will it take an initial investment of $1,000? So the P is going to be $1,000. To triple, if you multiply 1,000 by 3, you triple it. In your problem, the A is going to be 3,000. It's tripling the initial investment of 1,000. So triple, if it's expected to earn 0.6%, which is 0.06 for the R. If you plug in a 3,000 for the A, 1,000 for the P, 0.06 for the R, and do the same sort of algebra to solve for T, you'll get the answer that you need to get for problem 9. All right. Okay, 11 and 12. Immediately when I read problem 12, the first 2 words I see is how long. And when I read a money word problem, when I see the word how long, that tells me that I'm solving for t, because t is the variable that represents how long. Will it take an initial investment of $10,000 to grow to $15,000? So the starting amount of money is going to be a P, And in this problem, the starting amount of money is the initial investment, which is $10,000. The future amount of money is what the money's going to grow to. That's going to be the A. That's going to be a $15,000. If it's expected to earn 4% interest compounded continuously, I'm going to put 0.04 in for R, and I'm going to solve for T. So I'm going to plug those numbers into my formula. My formula is A equals PE to the RT. I'm going to plug 15,000 in for A. I'm going to plug 10,000 in for P and 0.04 in for R, and I'm going to leave the T alone. I'm going to start off by dividing both sides by 10,000. And I'm going to write a decimal on the left-hand side because it's going to make my work easier to do, and I'm giving a decimal answer anyway, so there's no need to work with the fractions. So 15,000 divided by 10,000 is 1.5. So this is going to give me 1.5 equals e to the 0.04t. Essentially the same algebra that I did with just different numbers from the last problem. Now I'm going to take the natural log of both sides. I'm going to leave the left side the natural log of 1.5. And on the right-hand side, I'm going to bring the exponent out front and make it a coefficient, make it 0.04t times the natural log of e. Since the natural log of e equals to 1, I can write natural log of 1.5 equals 0.04t times 1. Again, that's just using the fact that the natural log of e, I hit second and divide to get the e, is equal to 1. This gives me the natural log of 1.5 equals 0.04t. I divide both sides by 0.04, and I get the natural log of 1.5 over 0.04 equals to t. On my calculator, I'll do the natural log parentheses 1.5 divided by 0.04. It's going to be a time in years. So my answer is going to be this many years, and I'm going to round to one decimal place. So now it's just a calculator. Natural log of 1.5 divided by 0.04. And I'm going to say 10.1 years. The number after the 1's a 3, so I don't need to round it up to a 2. So my answer is just going to be, it'll take 10.1 years for the $10,000 investment to grow to $15,000. But just writing like that would be perfect. Here, problem 11 should be exactly the same. And we can move on to the last kind of problems. The last kinds of problems bring back the compound interest formula. And let me try to read through my problem 14, which is basically your problem 13 with just different numbers. So what will a $150,000 home cost in 10 years if the price appreciation over that period is expected to be 2% compounded annually? So I have 4 things underlined. Each of the 4 numbers or words that I have underlined turn into letters. The easy one is this 10 years. That 10 years has to be a T. Another easy one is this 2%. That 2% has to be an R, but I need to make the R into a decimal, so I'm going to be writing that as 0.02. A third one that's easy is this compounded annually. Annual compounding means the n is equal to 1. So this that I underline gives me n equal to 1. So in this formula, I have values for R, N, and T, and then I have one more number that's underlined. That's either a P or it's an A, which means I need to understand if that's a value today or if that's a value in the future. And the question is, how much will a $150,000 home cost in 10 years? That's the value of the home today. So I'm going to put that in for a P, which means I'm going to solve for A, and the A is going to tell me how much this house is worth in 10 years. I should have probably updated these questions. When I wrote this problem in Phoenix, it was $150,000 was probably the average home price. Now it's probably in the 2s for the average home price. But what I'm going to do is I'm going to take those values and put them into the formula. I'm going to solve for A, which is in this case, going to be how much the home is going to cost in 10 years. In for P, I'm going to plug 150,000. In for T, I'm going to plug in 10. In for R, I'm going to plug 0.02. And in for N, I'm going to plug 1. I'm going to pull down that formula. A equals P times 1 plus R over N to the NT power. It's really nice that I'm solving for A, which means I can go straight into my calculator. So I get A equals 2. I'm plugging 150,000 in for P, and then 1 plus 0.02 over 1 to the 1 times 10 power. And then if I don't want those ones in there, they're not necessary on my calculator. I think I left off a 0 here. Should be 150,000. On my calculator, I'm not going to be clever. I'm just going to enter that just like it looks, essentially. I'm going to go 150,000 times 1 plus 0.02 divided by 1. You don't need to divide it by 1. And then up arrow, let me be lazy and do up arrow 10. I'll multiply the 1 times 10. I don't know if it needs to be in a parentheses when it's just a single number, but I'll do it in a parentheses anyways. So 150,000 parentheses 1 plus 0.02 divided by 1 up arrow 10. Whether it's in a parentheses or not, I'll get the right answer. It says round to 2 decimals. So this house that's $150,000 now in 10 years is going to be $182,849.16. For my answer, I can say the house will cost $182,849.16. Quite honestly, if this was a test question, my key for the test would just have the number with a $sign, and that would be sufficient. So you don't have to give me the full sentence. If you just give me the number with the $sign, that would be fine. So your problem 13 should work real similarly. (15) and 16 are the same questions, just with different numbers. So if I remember what the numbers stood for in the last problem, I'll get them for this problem. So the first number I see is the value of a home right now. It's going to be a P. So a $300,000 home right now, what will it cost in 20 years? The T is going to be a 20. If price appreciation over that period is expected to be 2.5%, which is 0.025 for my R, compounded annually, the N is equal to 1. I'm going to plug those numbers into the formula and do a little less explaining. So I'm going to get A, which I'm finding that what the home is going to be costing in 20 years, equals in for P, plug 300,000, parentheses 1 plus fraction, in for R, plug in 0.025, over N, which is 1, and then to the N times T power, which is 1 times 20 power. And then I'm going to pull out my calculator, and on my calculator, I'm going to do 300,000, parentheses 1 plus 0.025 divided by 1. You could just type in 0.025. You don't need to divide by 1. And then I'm going to do up arrow 20. And this time I'm not going to put it in a parentheses. It doesn't need to be in a parentheses if it's just a single number. So 300,000 times 1 plus 0.025 divided by 1 up arrow 20. I'm going to round that to 2 decimal places. My cents are 93 and then a 2. I'm going to leave it at 93 cents. And for my answer, I'm just going to put in a box with a $sign that in 20 years, that $300,000 house is going to be worth $491,584.93. You can write a sentence saying the house will be worth this much money in 20 years, but you don't have to write a full-out sentence. All right, so 15 is your version of this problem. We just have one problem each to do, and it's basically the same problem, just in a different setting. Well, maybe we have 2 problems. No, we just have one problem to do. So 17 and 18, give me the formula that I want me to use. And in this case, My problem 18, it says the tuition at a local community college is $60 per credit hour. That's certainly not here. We're much more expensive than that. Although, I mean, there was a day, I think it was like $15 a credit hour when I took classes at GCC. I took classes at GCC in high school, which was like 1981. And I think it was $15 an hour then. Anyways, the tuition at the local community college is $60 per credit hour. Tuition is expected to increase at a rate of 3% compounded annually. What will the tuition be in 10 years? So I see number, something for an N, and a number. Let me try to figure out what each of these represent and figure out what I'm trying to solve for. The compounded annually, that's an N equal to 1 again. The 3% is an R equal to 0.03, and the 10 years is a T equal to 10. So I know from my work that I have certain values for R, which is 0.03, N, which is 1, and T, which is 10. Those numbers are freebies. I have to understand this $60 amount, if it's an amount of money, starting amount of money or an ending amount of money. And this is what the current tuition is, so this must be the starting amount of money. And I'm going to find the future amount of money, which is the tuition in 10 years. I'm going to solve for A. So I'm just going to plug those numbers into the formula. A equals P times 1 plus R over N to the NT power. Easy because I'm solving for A, so there's no extra algebra to do before I break out my calculator. So I'm going to get 60 times 1 plus 0.03 over 1 to the 1 times 10 power. And on my calculator, I'm going to enter 60 parentheses 1 plus 0.03 up arrow 10. I didn't do the divide by 1 because it's not really necessary, and I multiplied 1 times 10 in my head. If you do out the multiplication, the exponent doesn't have to be in a parentheses, but you can put it in a parentheses. So I'm going to go 60 parentheses 1 plus 0.03 up arrow 10. Round that to 2 decimal places, so it'll give me an error there if I left that parentheses. I'm going to say the tuition's going to be $80.63 per credit hour. So it will cost, if I want to do words, I'm fine. You can say tuition will be $80.63 per credit hour. Usually, I've never seen tuition that has pennies in the amount, so I might have just said round to the nearest dollar, maybe round that up to $81, but because it says round to 2 decimals, I'll round to 2 decimals. You can give your answer just as a dollar sign with the number, or you can do a short little sentence. All right, so that's the whole section. So we'll just stop here and just have two more sections to do in this chapter.